Okay, so at this point you've learned elimination and substitution and ways of solving a system equation. Today we're going to talk about how those apply to geometry concepts. We have this idea of congruent angle pairs with a parallel line, set of parallel lines cut by a transversal, things like corresponding angles, which could be like 1 and 5, alternate interior angles, which could be like 3 and 6, and alternate exterior angles, which could be like 1 and 8. Then there's also supplementary angle pairs. Things like 1 and 7 are same side exterior because they would be, or they would be supplementary because of that, and 3 and 5 are same side interior because they're on the same side of the transversal, and in this instance they would also be supplementary. So we're going to see how those, along with triangle sum theorem and exterior angles of a triangle, how those apply to system equations in geometry. So I'm going to work on this problem right here. It's going to require to solve with a system. Right now I'm going to find the values of x and y. What I notice right off the bat, although this is a trapezoid, I have a set of parallel lines driven right through the top and bottom here. And what I notice also is that if I cut this line as a transversal, I have a relationship between this angle and this angle. That relationship is same side interior. So I could say these are supplementary, as seen up here, which means I can set them equal to 180. So 2y plus 2x plus 12 is equal to 180. Now if I go across the other side, I have another transversal that I could cut between the two parallel lines, and I have another relationship between same side interior that I could set up as 4x plus y plus 6 is equal to 180. Now to solve this, as we talked about, I'm personally a fan of elimination, so I'm going to get it set up in that ax plus by equals c form. So I'm going to subtract 12 and just kind of reorder my x and y's for this first equation on the top. I'm going to do it over here. I'm going to write that as 2x plus 2y is equal to 168. If you notice, all I do is subtract 12 and then I flip-flop these because of commutative property. This one, all I have to do is subtract 6 because x is already in that front spot. I get 4x plus y is equal to 174. Now it's about solving this. Again, I'm going to use elimination, although this is perfectly set up for substitution. I'm just going to scale that top equation by 2 to line up my x coefficients. So based off that, I have 4x plus 4y is equal to, that looks like 336. And I have 4x plus y is equal to 174. Now that my coefficients are lined up, I could take this and subtract the two equations. I get 3y, and over here it looks like it's going to be a 162. And then if I want to solve for y, I divide by 3. And that's going to give me y is equal to 54. But as we talked about with systems, and as we see in the directions, I don't just need y, I also need x. So this is where I could substitute. I would substitute back into this equation to make my math a little bit easier. I'll do that over here. I have 4x plus blank, or 54, is equal to 174. Subtract 54 on both sides. I get 4x is equal to 120. And that instance, I can divide by 4. And x is equal to 30. And now I've solved, I've gotten x is 30 and y is 54 using system equations, specifically elimination. Let's do one more example to set up. Take a look at this guy right here. All right, I have a same setup. I have parallel lines driven right through the middle here. I'm still trying to find x and y, just how I set it up. That kind of matters here. So the first thing I'll notice is that I have my parallel lines driven right through here. And what you'll notice is, I have a transversal right here. So the first thing I'm going to see is that this and this are going to be corresponding angles. If corresponding angles, in this instance, corresponding angles are going to be congruent, so I could say things like x minus y is equal to 30. The other thing I know is that if I take this same transversal on this side right here, and I still have this parallel line with this parallel line, these two are alternate interior, meaning I could set this up as 2x is equal to 5y. Same thing as the last problem. I want to get these set up in ax plus by equals c form. This one's already set up for me, right? I just need to subtract 5y to get it on this side to get it set up in ax plus by equals c form. So the top is x minus y is equal to 30. The bottom is 2x minus 5y is equal to 0 because there's nothing over there. Just for practice, I'm going to use system of equations. I'm going to use substitution this time. So I have equation 1, I have equation 2. To solve for equation 1, I'm going to solve it for x because it's a little bit easier. So I get x is equal to 30 plus y. I'll move my hand in a second. This is my new equation 1 that I'm going to substitute in for. So I'm going to take this equation and plug it in for x right here. So that gives me 2 times the quantity of 30 plus y. That's me substituting for x. Minus 5y is equal to 0. This requires me to distribute. That's 60 plus 2y minus 5y is equal to 0. I'll combine like terms. So 60 minus 3y is equal to 0. Subtract 60. It's a two-step equation if you feel comfortable at this point. And then divide by negative 3. And y is equal to 20. So at this point, I get y is equal to 20. I'm not done again. We have to find the value for x. So I'm going to take that 20 and substitute back in for right here. I've already done the work. So this gives me x equals 30 plus 20. That's me substituting in for y. And I get x is equal to 50. So the answer to this question is x is 50, y is 20. In this instance, I use substitution as opposed to the last example where I use elimination. For your homework, feel free to set it up and use either method. We're not really assessing which one, just about what you feel comfortable with. Remember to scroll down to the bottom of the worksheet for the answer key and email us if you have any questions.